So it's my pleasure tonight to introduce our guest speaker, and this is Dr. Megan Gilbert, and she was raised, get this, on a cattle ranch.
Yes.
In the Cypress Hills north of East End. We actually did a field trip at East End. I don't know if you were working at the museum at that. Was about, how long was that, 7, 8 years ago? Yeah, you're probably doing your PhD.
I would be doing my PhD.
But anyway, we were down there and had a great time. Where the landscape at this particular place has many early treasures which profoundly shaped her passion for science at a very early age. This interest was fostered by proximity to the T-Rex Discovery Center, where as a teen, she worked as a tour guide and paleontology volunteer with the Royal Saskatchewan Museum. She completed her BSc in paleontology and geology in 2012, and her PhD was completed in 2019 at the University of Saskatchewan. Megan is now a research geologist at the Saskatchewan Geological Survey with expertise in Upper Cretaceous to Paleogene, vertebrate paleontology, stratigraphy, biostratigraphy, and depositional systems. You don't have much spare time, do you?
No. And that's not even my night job.
That's not even your night job. Anyway, welcome, and we're looking forward to your presentation.
Actually be able to see it, wouldn't that be nice? Okay. Okay, so share screen. Yeah, there. Share. And okay. Actually, I'm just gonna try. Okay, does that look okay?
Yeah, that looks fine. Thank you for having me to speak with you guys today. It's an honor. It really is. And thank you very much for the very lovely introduction. I appreciate that a lot. So yes, I work for the Saskatchewan Geologic Survey, and I basically have like no focus. So that's why I study so many different things. But at the end of the day, really what I'm passionate about is the Cypress Hills Formation, which I'm gonna talk to you about today. So I make, my everyday job, like today I was actually at the SEGA Core Conference presenting on the Manville Group, because that's what I do for my job. But as a hobby, I work on the Cypress Hills Formation. So as I said before, like as was said previously, I grew up here, and that's really what has inspired my maybe obsessive love with the Cypress Hills and the many earthly treasures that are found there. So as you said, you've already done a field trip to the Cypress Hills, so more or less, I'm sure everybody pretty much knows where that is, but it's in southwestern Saskatchewan, extreme southeastern Saskatchewan. The Saskatchewan side at least does boast the highest point in the Cypress Hills, so we got that going for us. This is a Google Earth screen grab of the Cypress Hills. So it's a very high elevation plateau in this part of Canada, and the highest elevation actually is equivalent to Rogers Pass. So it's not to be understated. So it really is like kind of this oasis of what's kind of like mountains. Not really like mountains because it's its own thing with its own geology, and it's not caused by uplift, or at least mostly not caused by uplift. But it is an uplands, and it's a significant uplands. And the scenery is spectacular. It actually has Rocky Mountain alpine forest. The glaciers never, at least as far as we know, never actually covered the Cypress Hills. So they have their own unique biota. Particularly when it comes to plants, there's many species of orchids, for instance, that only occur in the Cypress Hills that don't occur elsewhere. So it's a really unique place. And it owes its survival and existence during the previous glaciation event to the fact that it's covered in what? Like, what do we see in that picture? It's my presentation, so I get to ask you guys questions. Gravel, yeah, exactly. Yeah, conglomerate. It's covered in, like, the tops are predominantly covered in this conglomerate. So that is one of the reasons that it survived, is because conglomerate is obviously very, very resistant to being eroded away. So just to put it into a little bit of time context, the Cypress Hills and the surrounding area, so including East End, which is where I went to school, it represents a significant chunk of time. So at the base, in like around some places, you'll find Bear Paw Formation, you'll find Frenchman up onto the Ravenscraig. I'm sure you're like, you know, Ravenscraig being Paleocene in age. And then we get into the Cypress Hills Formation, which rests disconformably on the Ravenscraig. And then we have some Pliocene and Pleistocene deposits, which I'm not going to talk about today. But what I'm predominantly interested in is what we find here in the Maple Creek East End Swift Current area. So I understand that you've had a little bit of introduction to the Swift Current Creek beds, that maybe there's been some people who've done some talks on the Swift Current Creek beds. So those are related to this. I'm not really going to talk about them, but it's got a similar evolutionary history of how it came to be. So this is a shot taken just outside of East End. And what's the first thing you notice? If we look at this photo, what do we see?
Grass.
Yeah, well, we see grass and we see...
Squared off plateau.
It is a squared off plateau. Yeah, that's a good observation. That's a very good observation. Yeah, it is. What else? What about the trees? There are trees. Half of that is trees.
Is this looking south?
It's looking north.
Oh.
It's looking north.
The trees are all confined to a particular zone there, elevations.
Yeah, the trees only go so high. Why might that be?
They can't grow in the conglomerate.
They can't grow. Yeah, that's exactly right. They can't grow in the conglomerate. So the trees like to grow in the Ravenscraig Formation, which is silty and it's full of coal, and plants enjoy that, right? There's lots of substrate that they can use. Whereas the conglomerate, really, prairie grasses can make that work, but the trees can't. So when you look out on the Cypress Hills and you notice that all of a sudden the trees stop, that's where you know that you're all of a sudden getting Cypress Hills Formation. So that's our disconformity, is where the trees stop. So when you look at this in a little bit more detail, where do our grasses, so this is a road cut, right? We can see that there's a road here. And there's like all of these early colonizing plants starting, right? Like clovers and stuff, things that like to colonize first. And they only seem to go up so far, right? So right there, we have plants, because the plants like the Ravenscraig Formation. Ravenscraig Formation being Paleocene, right? And then we have the Cypress Hills Formation on top. And if we just casually have a look at that and we try to, you know, it's a photograph, so it's a bit hard, we're not physically there, but what do we notice about the sediments between the two? Color even.
Well, bottom is kind of gray and
Yeah,
kind of yellow.
because it's more organic. It's more organic, so plants really like to live in that, whereas the Cypress Hills Formation is very cobblestoney and sandy. Very, very sandy. So when you look a little bit closer on this contact, it's very abrupt. Like it kind of slaps you in the face when you see it when it's actually presented to you in a nice section. So right here, this is the contact between the Ravenscraig Formation and the Cypress Hills Formation. And you can see that it's infilled with conglomerate. So you noticed that the tops of the Cypress Hills are flat. Right, that's a very good observation, because most of the Cypress Hills, there would have been more sediments deposited on top of it, but they've been eroded away, and it's mostly just preserving the tops of the conglomerate. So the conglomerate is flat. It's flat lying. right? That's why the tops of the Cypress hills are predominantly flat. It's because there would have been more sediments deposited on top. They've been eroded away over time, and you're left with a conglomerate. So what's conglomerate? What kind of environment does it deposit in? Do we know? River. A very fast flowing river, right? So when you're walking along the tops of the Cypress Hills and you're walking along that flat base, you're walking on the tops of what would have been a river channel. Everything else above it is gone. But there's a lot more environments than just a river channel, right? And in some places we do actually have that preserved. And it's where we have that preserved that we find all the fossils of the Cypress Hills Formation. So there's not a whole lot preserved in the conglomerates. There's a little bit, but obviously that's going to chew up everything that's going to be deposited in it, right? So it's where we have stuff deposited on top, where we have preservation of the rest of the materials that would have come later, that we find most of the mammal fossils in the Cypress Hills Formation. So there's a lot missing, right? There's a lot of the Cypress Hills Formation that would have been deposited that's actually just gone. Thanks, glaciers.
Yeah.
Thanks a lot, guys. Okay, so this is a temperature curve, and I'm sure that we've probably all seen something like this before, where we have temperature along this axis, along the y-axis, we have time along this axis right here. So we have Paleocene, Eocene, Oligocene, Miocene. And what do we notice about the temperature? It's pretty stable, and then it spikes in the Eocene, and then what happens? It, boom, goes down, and then it kind of stabilizes throughout the Oligocene and the Miocene, and then what happens? Boom, it goes down again. So the Cypress Hills Formation cannot be understated actually for how important it is. Because so this is the Ravenscraig Formation, so it basically is spanning this time here in the Paleocene. The Cypress Hills Formation spans this time. And what's happening during that time? We're getting preservation of this decline in temperature. It's a pretty big change. It is a pretty big change. And what's change in temperature going to have an effect on? Turtles, for one thing, yeah. Turtles are one of my favorite things in the whole wide world, so yeah, absolutely. Turtles, reptiles, right? Reptiles are going to they're going to be affected, but what about, I don't know, I'm pretty much a lizard. Like, if it gets below 25 degrees, I'm having a bad time. I don't know why I live in Canada. And in Saskatchewan, no less, God. Yeah, like it's gonna have an effect on literally everything, right? The first things that are gonna be affected are, yes, go ahead.
What's the temperature based on?
It's based on mostly oxygen isotopes. Yeah, but there's a lot of different things that they can base it off of, yeah. So, plants are going to be affected, therefore animals are going to be affected, everything's going to be affected. So the Cypress Hills Formation spans a time where we went from having a very warm climate that was subtropical. In the Eocene, there was actually tropical or subtropical forests in the Arctic, to having grasslands. That's a really big change, right? Like if you can imagine, that's a very, very big change in environments. So we go from something like this to something like this. So what do you think that's gonna do to the animals living in this? You're gonna either evolve or you're gonna go extinct. Yeah, you're gonna have to figure things out pretty quick.
Move somewhere else.
Or move somewhere else. Exactly. Yeah. Like everything else, move out. So this right here is actually my study area. Okay, so right down in here, this is East End. So I actually grew up on a farm, or on a cattle farm here. Let me orient myself right here. So right in here.
Where's East End?
Right here. Yeah, right down here. So I grew up, yeah, right in here, right in this area here.
Where's the border?
The border? We don't have it on here.
Okay.
It would be quite a bit further south.
And then the border between Saskatchewan and.
Would be somewhere way, like kind of over here, somewhere. Yeah, I should have put a scale on this, but I didn't think about it. My fault. So all of this in here is known actually kind of through this area right in here is called the Conglomerate Creek Uplands. That's kind of the paleontologic, us mammal paleontologists, that's basically what we call it. Right in here is where I'm going to talk about today. So there's actually a whole bunch of sites throughout all of this, but I'm going to just focus on this one right in here. And it's because it's a pretty spectacular site. So this is a topographic map that I spent way too much time creating in Adobe Illustrator. So these are sections that I've taken. I'll come back to that in a little while. We won't worry about that right now. This is where this site is that I'm going to talk about today. So if you go south along this road here that I actually used to ride the bus on and get car sick, so this is the road to East End. It's about 9 kilometers. This is where the site is right here. This is a very, very well excavated site. So it was excavated by the Royal Ontario Museum, the Canadian Museum of Nature, and the Royal Saskatchewan Museum. In the 1950s predominantly, but it's been revisited in the 1960s and the 1970s. If you go to the Canadian Museum of Nature and go through the mammal gallery, almost everything from that gallery is from this site. This is called the Hunter Quarry, and it was found by a couple with the last name Hunter, so that's why the name was given to it. It is the most prolific bone bed, Paleogene bone bed in Canada that produces mammals. So the most prolific mammal Paleogene bone bed in Canada. It was worked extensively by all of these institutions, and they found tons and tons and tons of material that's from the late Eocene. This is a brontotherian skull, so you can see its nasal horn core is right here, in the back of its skull right here. This is the cheekbone, the zygomatic. This would be the front of the skull right here. This is another piece of material right here. This is the site today. So what ended up happening is that this site was worked prolifically, and that I do believe it was the Canadian Museum of Nature, but I might have that wrong, but I think it was the Canadian Museum of Nature was out there, and they were working the site, and they were finding tons of stuff, and they went around the corner and went for lunch, and they heard whomp. And they came back, and the entire site had slumped. Yeah, and they were like, well, I guess that's the end of this field season because we don't have time to like dig the entire thing out. And then nobody ever really went back. And there's reasons for that. I won't get into it. If you want to ask me about the particulars of that, there are reasons that nobody ever went back. Well, you can ask me afterwards, but nobody ever really went back. This is all a spoil pile, just to put that into perspective. This would have been one big hill. So they took this back a lot. They actually hired the rancher who owned this land at the time to take his tractor in and like take off the hill. So they did a lot of work in here, and they actually quarried in, like they dug tunnels into the hill, like you would with a mine, like a coal mine, to get more bones out. It was an unbelievably prolific site.
Are you going to talk later about how this site was made, like in terms of the sediment?
Yes. Oh yeah, we're getting there. Don't worry. That's the point, actually. Yeah, absolutely. That's absolutely what we're going to talk about.
Excuse me, so the white layer is the rock sitting above the conglomerate. Is that correct?
Oh, you're stealing my thunder.
We're just getting anxious.
Yeah, we're just on the edge of our seats. I'll get to that.
Yeah.
I'll get to that. Don't you worry. Don't get anxious. Okay, so there's 3 sites here, actually. There's 3 sites. There's Calf Creek South, which is actually down and around the corner, and it's about 600 meters, about a 600-meter hike. It's actually lower in section than this site here. I knew it existed, and I have refound it. So it hasn't been worked at all, but it's something that exists. It's known. I'm hopefully going to get to that this summer. So maybe I'll have more to tell you next, like in the next 6 months or so. This is the Hunter Quarry, and this is actually the Calf Creek micro-locality. So there's a little creek that runs through here. Depending on who you talk to, we call it different things. Some people call it Calf Creek, some people call it Rose Creek, some people call it Pollock Creek. It depends on what map you look at. But there's a little creek that runs through here, so that's what gave it its name, Calf Creek. So there's a micro-locality here. So between all of those, well, not this one because it's never really been worked, but between these 2 sites, there's over 3,500 specimens collected. that have been cataloged. There's a lot more that have not been cataloged. That's a lot of material. At least 60 different taxonomic families that have been described so far. There's a lot that hasn't been worked on as well. And it's the most extensive multi-taxonomic mammalian Paleogene bone bed in Canada. It is the highest latitude mammalian, like the Cypress Hills in general is the highest latitude non-polar fossil assemblage in Canada. So it's a pretty big deal, right? Like we're not dealing with polar species, we're dealing with non-polar species. And so it's a big deal that we have this in Canada. It's really a very unique thing. So because of this, we can basically say something about what all the animals are that were living here. So there's been a handful of people who've published on this, particularly John Storer, who's been my mentor for the last few years on this. We know that there's, the giant pigs, the entelodonts. We know that there's a couple different species of leptomerics, which are the small deer. We know that there's a few different species of early horses, three-toed horses. We know that there's a couple different species of brontotherium. There's the typical Megacerops coloradensis, which is the one that you would see in Drumheller. That's actually, I do believe that those ones are actually from Saskatchewan, those ones that you see there. And there's also the one that had the two-pronged nasal horn course. They also find early cats. You couldn't really call them cats at that point, but they were kind of getting to a point where they looked cat-like. All kinds of different things. Hyenodons. It preserves the ecosystem, what the ecosystem was like at this particular point in time. But my question became, okay, that's great. We have all these specimens and we've identified at least certain species, but we haven't really put them into a context. There's never been anybody come along and actually publish the geology of the Calf Creek locality. And the last person who published, well, I guess until I published something last year, but until that point, nobody had published on the Cypress Hills geology, like the Cypress Hills Formation geology, since like 1989. So that's a long time. We've learned a lot about geology since that time. So I was like, okay, well, maybe we should actually be looking at the geology and maybe we can take the animals living in there and see if they match. Like, are the things that we're seeing in the geology match what we're seeing in the animals living in these sites? And so that's what I've been setting out to do. Okay, so what I did is I took a bunch of time off work and I went out here and I started measuring all of these sections. So we have 1, 2, 3, 4, 5, 6. I measured all these sections. So all in this little area right here. And luckily, we do have preservation of stuff above the conglomerate. So we're seeing conglomerate and then above. So I'm gonna walk you through the stratigraphy and what we see in all the geology, and then we're actually gonna look at the animals and see if it matches. Ready? Buckle up. Okay, so this is a really like a bunch of simplified cross section, this is a simplified cross section based on sediment logs. So this is Calf Creek South, which is the site that I told you existed just a little bit further down the valley, but I haven't collected from yet. This is the Hunter Quarry itself. This is the screening locality across that I showed you. This over here is a road actually that leads into the site, basically from the bottom to the top of the hill, and then you come back down into the valley. This is across the valley, number 6, and then we have another locality just a little bit further away. So if we go back over here, so we have 1, 2, 3, 4, 5, 6, if you can kind of remember that. We have 1, 2, 3, 4, 6, and then 5, just because it is a little bit neater to put it that way. It makes the geology a little bit tidier. So we're gonna step through this. Okay, so this is how I'm dividing out the different environments, because what we do in geology is we take a bunch of measured sections and then we break it up and we're like, okay, well, what environments do these belong to, right? Can we figure out the different features of them and figure out what kind of environment it is? So this is the first one I'm going to go through, is the conglomerate. The base of the section is conglomerate, and it is class supported conglomerate. So if you can imagine how much energy it would take. And when you look at each one of these individual clasts, they have percussion marks all over them. So that's caused by clasts hitting each other at super high speeds, right? Can you imagine how much force it would take to do that? And I'm a little bit underselling it here. Where do you think these come from? These have to come from somewhere. They didn't just magically appear, right? Where do these clasts come from? Yes, they're belt supergroup. So these are quartzite, metamorphosed sandstone. So if you can imagine making percussion marks on metamorphosed sandstone, it takes a lot of force to do that, right? And they're very rounded. They are very rounded, yeah. And depending on where you are, like if you move to different sites across the Cypress Hills, sometimes they're like this big. And making trough cross bedding out of conglomerate that size. Like I know, it's hard to imagine so much force, right? You need a lot of slope to create water moving that fast to produce this, right? So the bottom of the section is this conglomerate, which, what kind of environment? Fluvial environment, right? Braided rivers, right? So we're in the middle of a braided river channel. So like when you maybe go out to the Bow River or something, or some of these mountain streams, and you stand in the middle of it, what do you have? It's cobbles, right? A bunch of cobbles. That's exactly, if you go out and stand in the middle of a river just to the west of Calgary, this is the exact same type of environment you're gonna have. Okay, so imagine that in Saskatchewan. Yes, that's the appropriate answer, or the reaction. Then we have this group of facies, which, you know, we lump into an environment. And it's all this cross-bedded sandstone. So when you think about a river environment, as you move towards the banks, what do you get? You're standing in the middle of your cobbly river, and then you move to the side. It drops out and you get sand. Exactly. So yeah, you get sand. You get sandbars, or, you know, the banks of the river can even be sandy depending on what kind of a river it is. So this is cross bedding, right? We can see that right here. Here's some more, right? We can see that it's cross bedded and ripple bedded, right? And we get this strange stuff in here, this kind of yellowish looking material. It's calcite and silicate, actually, that's been like dumped into the system. So what's happening is you're getting flooding episodes on the, you know, you move towards the side of the river, you're starting to get towards the bank, and maybe your bank overfloods sometimes and it picks up material and just kind of vomits it out onto the side, right? So that's the kind of thing we're getting. These are called, they're basically a breccia of just garbage material that's being picked up and dropped. And then we move into this facies up here. And it's all this silty sandstone. Okay, so it's like kind of interbedded silt and mud and sand. So as you move further out into, like from your side of the river, you've moved out, what do you start to get? You get overbanks. Exactly. You start to get overbanks. So when you look at this a little bit more closely, you're starting to see, you know, loosely cross-bedded sandstones or ripple-bedded sandstones. You're also getting some green clay stones mixed into this. If you move a little bit further away from this site, you start to get thick beds of green clay stone. You know, maybe you're getting ponding or something on the side, right? There's been a few places, I should have included photographs of it, but where you actually get insect bioturbation as well. So you're starting to see like, you know, insect nesting traces. So we know that we're kind of moving away from our active river environment and getting into something that's more slow moving, okay? So I'm just actually gonna go back for a second here. So in this stuff right here, this is actually the environment that the Hunter Quarry is deposited in. So it's these fine-grained, kind of reddish sands that are cross-bedded right at the boundary between that cobblestone and that sand is where we're finding a lot of those fossils, and throughout. So before I move on here, let's think about this. So we clearly are in a fluvial environment, right? We're getting a braided river that's maybe ephemeral, like flowing really high at sometimes, maybe a little bit less, there's some seasonality to it. If we think about animals and environments, maybe why would we be getting them here? When you think of the spring, what happens?
There's lush green growth.
Right.
You've got water and new greens.
Right. So what happens in the spring? The water becomes more fast flowing, and maybe if you have animals that are moving into other areas, right? Think about pronghorns. They do what? They migrate a little bit, right? They move around a lot. And if you're having animals come up and starting to move maybe across these river systems in the springtime, and then they're getting caught in these and dying, or even, maybe they're being killed off at certain points, and if the water comes up and moves them all into the river, it's depositing them, right? So there's a mechanism for that, right? So there's a reason why they're all depositing in this river system. And there's probably some kind of seasonality to it. And there's other sites that I've worked on that would suggest that as well. So if you want to ask me questions about that, you can later. So again, we have all of these interbedded sands and silts, and they're full of, we have root traces in them, and we also have all these insects as well. As I've shown you, cross-bedded sandstones and interbedded muds and sands and muds and sands and silts. It's a very heterolithic deposit. So kind of your classic overbank or floodplain deposit. So this is the kind of environment we're getting. So we have some kind of incision, right? Some kind of incision that's taking place. And then we have a river that's moving through this valley system. And then you have all of your sub-environments on the side, right? Like your sandbars, and then your floodplain, right? Your floodplain is kind of all this whole area right in here. So that's akin to that's what the Cypress Hills Formation would have been deposited in, as something like this. So how much slope do you have to deposit coarse cobblestone conglomerate?
Is it slope versus water force?
Well, you need slope to create water force a lot of the time. So how familiar are we with some of Montana's geology? What do we have around Montana? However, Montana has what? There's a lot of igneous intrusions. Yeah, there's a lot of igneous intrusions, and they're Eocene to Miocene in age. So the going theory is that these intrusions were active and that they were uplifting and creating enough slope that it was draining the river system into basically Hudson Bay with so much slope that it was eroding all of this cobblestone off of the belt supergroup, which was being exposed, and filling in a valley system.
Do you see clasts of these igneous intrusions in your drawing?
Yes, there are clasts of granite, there are rhyolite, there's kimberlite as well. I found pieces of kimberlite. There's also gold. There's gold in the Cypress Hills Formation as well. So that would lend itself to there's some sort of igneous mechanism, at least in part, controlling something in here.
There's belts, rocks exposed in Montana.
There are belt supergroup exposed in Montana. Yeah. Mm-hmm. Mm-hmm. So far what we're getting here is some kind of river environment, right? We have a very nice sequence of what is clearly a river system of some kind. But to me, it's like, okay, well, what does this say necessarily? Like, what else can we say about this? So we know that we're getting silcretes and calcretes. That might indicate that we're getting some kind of, maybe semi-arid environment, perhaps. There's no coals. And I don't know, how many of you have spent a little bit of time in the Cretaceous? Looking at Cretaceous rocks. Like, have you ever been to Dinosaur Provincial Park or the Horseshoe Canyon area? Right, like that's, a lot of that is floodplain or rivers, and it's overbank deposits in some places. And one of the things that you commonly get is coal, right? And we don't really see any of that, right? We're not really getting a ton of evidence like that. So it's like, okay, well, why? Why are we not seeing those kinds of things, those kinds of signatures? So what I decided to do is myself and my co-worker, I guess, whose name is Frank McDougall, we would look at all of the mammals found at the Calf Creek site. We'd start with the Calf Creek site because there's so many organisms, or there's so many mammals preserved, as well as a lot of other different things, reptiles and whatnot, that maybe we could tease out something about the ecosystem from all of the organisms that are in this environment, that are preserved here. So Frank and I went through all of the literature, as well as, and we're still going through the Royal Saskatchewan Museum collection, and anything that's ever been published on the mammals from this site. And we decided to measure their teeth. So I'll get to that in a moment. And I mean, there's all these different kinds of yeah, I'll get to that in a minute. Okay, so what we're gonna use is we're gonna use cenograms. And this is a graphical representation, basically, of using maths, which is very difficult. So it's math, right? None of us really like math. So cenogram, a graphical comparison of the average adult weight of mammal species in a terrestrial area to draw conclusions about paleo environments, including whether the area is species rich, its relative humidity, and level of forestation. So basically, it's using the animals that you find in a site to tell what kind of environment you have, whether it was rainy, whether it was arid, or something in between, and how much forest cover you had. So you're probably thinking, well, how in the world do you do that? Using an XY plot. So you put species on this side, on the x-axis, and you put their weights on this axis. And it creates an ecological gradient. And there's been a lot of this done with modern environments, and we can use modern environments and compare our mammal environments in the past and use it on this. So in a tropical environment, this is the slope that you get. So what you do is you take a measurement of their weight, you put it into a logarithmic formula, and you calculate it, and you put it into an XY plot, and you take the heaviest animal, or the heaviest animals and the lightest animals, and you line them up, going from, one to the other, and then it creates a slope. So when you have an environment that is tropical, there's a lot of resources, right? There's a lot of water, there's a lot of resources that are available. You get a slope that basically looks like this. In something that's semi-arid, like maybe the savanna of Africa, you get a break right here in the 500 to 600 gram animals, because there's just not enough resources. You start everything starts to kind of fall apart a little bit, and you get between the 500 and 600, you don't have as many animals. And then in arid environments, this is what you end up with, because the land just can't support that many animals, right? Make sense? Okay, so what Frank and I did is we took all of our species and we measured their first right lower molar. So what you do is you measure the length, and then you measure the width, and you put it into a calculation, and then you convert it to a logarithmic formula, and you come up with a bunch of numbers, a whole bunch of numbers. So we did it for every single species that we knew existed in the Calf Creek locality. So in the Sahara, and what we did is we compared it to the Serengeti. So we were thinking, okay, well, maybe let's start with the Serengeti, because that's something that, all of our environments are showing us that we have a lot of river systems. It doesn't really look like we have a ton of vegetation. So let's start with that. So in Tanzania, you have the Serengeti. You have horses, right? We have horses in our site. We have all of these different ungulates and whatnot. We have a couple different cat species. That's kind of similar to what we're seeing in the Cypress Hills Formation. And we also used this park right here in Rwanda. So the Akagera National Park, again, similar kind of structure. We thought we'd use 2 parks just to see what we get. So this is Akagera Park. This is the spread that you get using mass and grams in log and rank mammals by mass. So from smallest to largest. This is the Serengeti Plain. So similar, right? We're getting a break here, right? Because it's semi-arid. So you can see that there's a little bit of a break here. This is the Calf Creek site. So what does that tell us? Yeah, it's telling us we have an environment very similar to the Serengeti Plain. Something similar to Africa, where you have something that's semi-arid, probably, you have ephemeral flows and whatnot, and you're seeing the same kind of spread in mammals. So the next thing that we want to do is there's a whole bunch of these sites in the Cypress Hills Formation. There's a lot of these sites. So we want to take all of the sites where we have enough material, and we want to do the same thing. And through this section, because the Cypress Hills Formation spans the late Eocene through to the earliest Miocene. And we want to do this for every single site that we have enough material for and see how that changes over time. So here in the late Eocene, we can say, hey, we're something similar to the Serengeti. But what are we going to look like by the time we get to the Miocene, right? And we know that we're getting colder. So that's going to have an effect on the biomass and the animals that the land is able to carry, right? So far, this is the reconstruction that was originally done by John Storer that's holding up. Essentially, you have something that's like semi-enclosed. You have patches of forest, just like in the Serengeti. You have a lot of larger animals, and you have a little bit of a break between the 500 and the 600 gram animals, but overall you have a moderate carrying capacity. So the conclusions and future directions of where we're planning to take this is our study area consists of a row of coarse-grained braided channels at the base, shifting to floodplain, lake, and meandering channel systems, and back to coarse-grained braided channels at the top. So I didn't show you, but like at the very top of the Cypress Hills, you get more braided channel systems. The sonograms reveal the environment consisted of semi-closed canopied forest in a semi-humid to semi-arid environment, right? It's mirroring the Serengeti of Africa. That's exactly what it is. It's similar to the modern-day Sahara of Africa. Constructing sonograms of other grassland ecosystems for comparison, right? So it's great that we've done this for Africa, but how does it stand up to other grassland ecosystems that we might be able to compare it to? Continue reconstructing more fossiliferous sites in the Cypress Hills based on lithology and where we can produce sonograms from, where we have enough material to actually produce sonograms, and compare these through time, as there are sites that span the Oligocene to the Miocene, and we know that the temperature was continuing to decline. So what can that tell us over time? All right, and that's what I got for you. So if you have any questions, please, by all means, let me know.